linear dependence of set of vectors. Now, a set of Rn x1, x2 up to xr is linearly dependent if there exists R scalars, that is k1, k2 up to kr, not all 0, such that k1 x1 plus k2 x2 up to kr xr is equal to 0. And here 0 is a vector whose components are all 0. So let's actually look at an example. So let us say x1 is equal to 1, 2, 4 and x2 is equal to 3, 6, 12, and taking this equation k1 x1 plus k2 x2, because there are only two vectors, this will be equal to the 0 vector. Okay, so now let's substitute the values. So k1 x1 is 1, 2, 4 plus k2 times x2 is 3, 6, 12 is equal to, now let's write this in this form. Let's simplify this now. So k1 times 1 is k1 plus 3k2, then we have 2k1 plus 6k2, and then we have 4k1 plus 12k2 is equal to 0, 0, 0. And based on the equality, we can say k1 plus 3k2 is equal to 0. 2k1 plus 6k2 is equal to 0. 4k1 plus 12k2 equal to 0. Yes. Now this can be simplified as we take 2 common out, so this becomes 2k1 plus 3k2 equal to 0. This becomes, if we take 4 common out, so we get 4k1 plus 3k2 equal to 0. So all are same. So we have k1 plus 3k2 equal to 0. Now, which basically means that there are many values of k1 and k2 which satisfy this equation. Okay, so basically which means that we take a value for k1 and we evaluate the corresponding k2. So if k1 is equal to 6, so 6 plus 3k2 equal to 0, 3k2 is equal to minus 6 and k2 is equal to minus 2. Similarly, if we take k1 is equal to 5, we get 5 plus 3k2 equal to 0, 3k2 is equal to minus 5 and k2 is equal to minus 5 by 3. So which means we have infinite number of solutions, right? So here if you notice k1, k2, they are not zeros. So as per our definition, not all 0, we can say that x1 and x2 are linearly dependent. See, one of the solutions, the simplest solution, which is also called the trivial solution, is when k1 equal to 0 and k2 is equal to 0. So this is also a solution, but this is the case with all the cases. So what is more important is for us to figure out a non-zero value, which means that if k1, k2, k3, they are all zeros, then we would be calling them as linearly independent. So a set of Rn vectors x1, x2 and so on up to xr is said to be linearly independent if every relation of the type k1 x1 plus k2 x2 and so on up to kr xr equal to 0 implies that k1 equal to k2 equal to kr is equal to 0. That means they are all zeros. So let's do an example and see. So let's say x1 is equal to 3, 1 minus 4 and x2 is equal to 2, 2, minus 3. So again k1 x1 plus k2 x2 is equal to 0, which implies k1 3, 1 minus 4 plus k2 2, 2, minus 3 is equal to 0, 0, 0. Okay. Now k1 3k1 plus 2k2, then we have k1 plus 2k2, then we have minus 4k1 minus 3k2 is equal to 0, 0, 0. And based on equality, we can say 3k1 plus 2k2 is equal to 0, k1 plus 2k2 equal to 0, and minus 4k1 minus 3k2 equal to 0. Let's rearrange this. Let's say k1 is equal to minus 2 by 3k2. This will become what? K1 we have already found. So minus 2 by 3k2 plus 2k2 equal to 0, which means minus 2k2 plus 6k2 equal to 0, which means 2 we take it out, or 6k2 minus 2k2 is 4k2 equal to 0, k2 equal to 0. k2 is equal to 0 means what? k1 is equal to 0. And similarly here, k1 is 0, k2 is 0. Therefore, this is also satisfied. Now here, k1 is equal to k2 is equal to 0. So therefore, the vectors are linearly independent. Okay. Now, important points. A set of one vector, there is only one vector, is linearly independent. Okay. A set of two vectors is linearly dependent if one of them is a multiple of the other. That means both the vectors will lie on the same line. Okay. Third point. A set of vectors containing the zero vector is dependent. Okay. If a set of, or rather a set containing more vectors than there are entries in each vector, then we say the vectors are linearly dependent. Okay. What does this mean? It means if you have A is equal to vector 1, vector 2, vector 3, and so on up to vector P, and it is a n by P matrix. If P is greater than n, then Ax is equal to 0. Here in this, we will have more variables than equations. Ax equal to 0 has non-trivial solutions, and columns of A are linearly dependent. Remember, columns are vectors. Remember here x in Ax equal to 0, x is nothing but x1, x2, x3 and so on. These are the scalars, and A is the set of vectors. So we will have v1, v2, v3, and we will have x1, x2, x3 equal to 0, 0, 0. So if we do the multiplication, we will get x1 v1 plus x2 v2 plus x3 v3 equal to 0. Remember here x1, x2, x3, previously I have been using k1, k2, k3, right? So you should be in a position to figure out which is the vector and which is the scalar. Now if notation wise it is written properly with vector notation, then it's much more easier to figure out. Okay, and in short this can be written as a x equal to 0. Okay, I think that's enough. Bye.